Business Finance Chapter 10. In Chapter 10, we continue looking at the stock market and stock values, and we add in calculating for stock risk and some history about the stock market. So first, we talk about the risk-return trade-off. So we have two key lessons from the capital market history. There is a reward for bearing risk. And the greater the potential reward, the greater the risk. So we know that there's potential reward from investing in the stock market, but that there's also risk involved in that. So we're going to look at a lot of capital market history or stock market history and discuss the historical returns and use those to calculate risk. So when we talk about dollar and percentage returns, we have our total dollar return, which is the return on our investment measured in dollars. The total dollar return equals the amount of any dividends we have received plus any capital gains we might have received. And our capital gains are the difference between the price that we paid for the security and the price that we received when we sold it. Our total percent return is the return on that investment measured as a percentage of the original investment. So we have the dollar amount of our return divided by the dollar amount invested gives us the percentage amount of our return. When we're calculating what our percent return is, this is our dividend yield plus our capital gains yield. So we look at our dividend yield is dividend divided by the price. And the capital gains yield is the price we sell for minus the price we paid divided by the price we paid. So then we take those two, our percent return is our dividend yield plus our capital gains yield, or our dividend plus the price we received when we sold it minus the price that we paid divided by the price that we paid. So let's look at some examples. So we invest in a stock with a share price of $25. A year later, that stock is now priced at $35. And we received a $2 dividend from the stock. So our dividend yield was the $2 divided by the price of our stock, or 8%. Our capital gains yield was the current price minus the price we paid divided by the price we paid. So our capital gain yield was 40%. Our total return then was our dividend plus our capital gain divided by our original price, or a 48% return on that stock. This next slide looks at the average returns for the stock market investments as a whole from 1926 to 2017. There are many more charts and graphs in your textbook for Chapter 10 that show how the stock market has changed during that time period, the rate of growth, and you can see a linear graph across those 92 years showing the growth of stocks. When we look at just the average return of certain investments, we see that small company stocks had the largest average return. So the large stocks that are termed large stocks, those are the S&P Top 500 index stocks. And the small stocks are the 20% of the New York Stock Exchange smallest stocks. So this is just a research that was done on the entire capital market over this 92-year period in order to look at average return. Our long-term corporate bonds and then long-term government bonds. And then the lowest return being from the US Treasury bills or T-bills. We also need to know that the average rate of inflation over that period was 3%. So when we're looking at these returns, these were our nominal returns. If we adjusted them for inflation, for example, we have 3.4% average return on US Treasury bills and inflation of 3%. That means that given the rate of inflation, the real return on US Treasury bills was actually 0.4%. So this average return is not adjusted for inflation. The long-term corporate bonds and the long-term government bonds are bonds with longer than 20% maturity or 20 years to maturity. So when we look at that historical average return, that is called our simple or arithmetic average. So it's the sum of all of our yearly returns divided by the time. So the sum of the returns for large company stocks from 1926 through 2014, we get about 10.77 over 89 years. So our best guess about the size of return for any year is selected at random is 12.1%. We also need to look at risk premiums of information. So what is the kind of risk? When we look at the average returns, we want to know how they compare with each other. So we want to compare them to similar types of investment with risk. Or an interesting comparison involves T-bills or treasury bills because they are virtually risk-free, especially when we look at the very risky return on common stocks. So the difference between the two types of returns can be called an excess return because it's the additional return we earn by moving from a relatively free risk investment to a risky one. Because it's interpreted as a reward for bearing risk, we call it the risk premium. So that's the extra return you get by taking extra risk over investing in something that has a very low risk. So our reward for bearing risk. When we look at historical risk premiums, this is comparing them to the US Treasury bills. So the US Treasury bills have zero risk. Large stock companies, remember those are the 500 stocks on the S&P, top 500, then as compared to US Treasury bills have a risk of 8.7%. The smaller stocks, even though they returned the highest return, if you look at the historical linear graph over the 92 years, they had very volatile highs and lows, more volatile highs and lows than any of the other investments that are looked at in this chapter as part of this historical research project. Risk is measured by the dispersion, spread, or volatility of returns. So this graph is a frequency distribution of the returns on common stocks from 1926 to 2017, showing that more stocks were around the 10% return than the others. So we see the frequency distribution, and then we can see standard deviations between the average. And as we move out on the graph, we can see that we have ranges from a negative 50% return to a 60% return on the original investment in any single one of these stocks. So we need a measure of how volatile the return is. The variance and its square root, the standard deviation, are the common measures that we use to assess the volatility or the risk of these. So when we're looking at the return variability, we're going to use the variance and the standard deviation. So the variance is a common measure of return disbursement. And then the standard deviation is the square root of the variance. It's sometimes called the volatility, and it has the same number of units as the average. On this next slide, we're going to see the mathematical formulas. So the variance is the sum of the return minus return to the power of 2 over the number of returns minus 1. And then the standard deviation is the square root of the variation. So we're going to be looking at these examples during our example review in class. We're going to be calculating the variance and standard deviation for items. So here's an example of the historical variance and the standard deviation. So we're looking at a range of years from 1926 to 1930. We have the returns, the average return, which is the sum divided by the number of years that we're looking at. We see the difference between the two, which is the variance between the two. And then that squared, and then we get our standard deviation. So we get a variance of 859.19 and a standard deviation of 29.13. We then can graph that information to look for a normal distribution. We should see a normal distribution from these results very similar to the histogram or distribution graph that we saw earlier. So normal distribution is a symmetric frequency distribution, also known as a bell-shaped curve. It's described by the mean and the variance. So does a normal distribution describe asset returns? Well, let's look at some examples. So we have the illustrated returns are based on the historical return and the standard deviation for a full portfolio of large common stocks. So we have the return on large common stocks and the probability of that return. Then we have 1 minus our standard deviation, 2 minus our standard deviation, minus 3 our standard deviation, plus 1 our standard deviation. So the actual distributions are roughly mound-shaped and symmetrical. When this is true, the normal distribution is often a very good approximation of the actual distribution. We want to keep in mind, though, that the information that we're looking at is based only on 92 yearly observations. Well, in principle, this could be based on an infinite number. So if we had actually observed returns maybe monthly over 92 years instead of annually over 92 years, we might have seen a bigger variance with a lot more irregularities that don't show a graph or distribution that is as clean as what this bell curve that we have here. The usefulness of this normal distribution is because it's completely described by the average return and the standard deviation of the average returns.